Hi, today we are going to solve this problem, the number of longest increasing subsequence. So in the short we call out LIS. Okay, so what I recommend before looking this video, I have already made a video on to find the longest increasing subsequence. The LeetCode problem is 300. So this is the extension of that. In earlier problem, we found what is the longest increasing subsequence from the given array. Okay, and then here the problem is asking how many number of such longest increasing subsequence possible. Okay, so the solution, there's many solutions you'll find out, but the solution what I'm talking is the nlogn time complexity. Earlier problem is also solved based on the nlogn. So the solution of this problem is just an extension of earlier problem. That's why I'm recommending to look at the LeetCode number 300 solution what I have provided in the earlier video. I'll put the link here also in this video. Okay, so we'll start. So just give an example 13547. If you look at the longest increasing subsequence is having a number 4, 1, 3 and 4, 7 is the 4 is the length of the subsequence having increasing subsequence, right? And then there was two such kind of subsequence are possible. One is 1, 3, 4 and 7. Another is a 1, 3, 5 and 7. Okay, that is the reason output is 2. Okay, for here the longest subsequence is only 1. The number of longest subsequence is just a 2. And how many are possible? 5, because there's 5, 2 is given here. Okay, we'll look at a couple of examples for better understanding. Then we'll go to the solution. So I'll take the example of this. This is the example given in the LeetCode number 300, longest increasing subsequence, and how I solve there. I will start from there so that the resemblance of this solution would be better understandable. Okay, so what I did earlier, I used a sub-array, okay, and I did a binary search because it's the longest increasing subsequence, right? Somewhere the number is increasing, so I try to use the binary search, and then solution became nlogn. So as a recap, so what we did earlier, we took a 10, okay, the first number, then we took a 9. Since 9 is smaller than 10, so we looked at what is the position of 9 in this given subarray by the binary search, and we found it's a 0. So we just replace the 9 from the 0, okay. So I'm replacing it with the 9. Then we look at the another number. This is 2. 2 is again is smaller than 9. So we will do the binary search, and finally the index would be 0, where this will be replaced. Okay. Then 5 is greater than 2. So we'll append the 5 here. 3 is smaller than 5. Again, in this subarray 2 and 5, we'll find the position of 3 and we'll replace the number. So here the 5 is right in place of 5, we'll take 3. Then 7 is greater than 3, no problem. 101 is greater than 7. 18 is not greater than 101. So what I'll do, so with this subarray I'll find the index of 18 and replace. So here the 18 will come between 7 and 101 and replace with the 18. Okay, so ultimately the solution was 2, 3, 7 and 18. The longest increasing subsequence number is 4. Okay, now the question is that how many such subsequences are possible? If you'll see here, the 2, and this is also possible, 2, 5, 7 and 18, 2, 5, 7 and 101, 2, 3, 7 and 101, 2, 3, 7 and 18. So I'll just write down here. So how many such numbers subsequences are possible? 2, 5, 7, 101, 2, 5, 7, 18, then 2 3 7 1 0 1 and 2 3 7 18, right? So this is the 4. So the answer of this question will be 4. Okay, now how to find these numbers? So just to give understanding better, now in place of array, when I was replacing after doing the binary search, will not replace, we'll just add in the same array. So we'll have a list of list, and then what we'll do, we'll start from here for understanding. So 10, okay, this is the first number. I'll add the 10 here. Okay, now 9 is smaller than 10, right? So what we'll do, we'll replace, in earlier problem we were replacing the 9 with the 10, right? Here we will not replace, we'll just add in the same list. Next is a 2 is again smaller than the 9, we'll add here. Okay, now 5 is greater than 2, right? So we'll close this array and start new one. Okay, this is the 5. Now 3 is smaller than 5. Okay, so what we could have done, we could have replaced this 5 with the 3, but we will not replace, we will add here. Okay, now 7 is greater, so 7 is appending, right? So what we will do, append the 7 here. Okay, now 101, so 101 is also not replacing 7, so we'll close this one and append 101. Okay, what about this 18? 18 is replacing 101, so we'll add the 18 here. Okay, now it will give me the fair idea, right? So with all this, so if you look at this, 5 and 3 is the two combinations, right? So 5 and 3, we have the two combinations that's possible. 101 and 18, again we have a two combination, the possible combinations, right? And then 10, 9 and 2, these are the single combinations what we have. So with this, we're not able to find the account. So what we have to do, for each of the number, we have to associate the count as well. So how many such substrings or sub arrays possible? Not substring, sub arrays possible. I'll just show you. So I'll take a sub list. Now in place of just adding a 10, I'll add the count. So I'll just take a tuple. So first number is 10. Okay, so 10, nothing is there, so I'll simply take a 10 and count is 1. Good. Now 9 will replace the 10, right? So what we'll do, 9 and how many such single one? So this is 1, right? So I'll check if 9 will replace the one binary search, right? And then if yes, then what is the count here? The previous one is 1. Okay, so I'll make it 2. Good. Now the next number will come as a 2. So I'll take a 2. I'll check. Now if this is replaced, so where this 2 will be adding? So 2 will replace this guy, 9. What is the count? 2. So my next count would be 3. Okay. Now 5 is greater than 2, right? So what we'll do, we'll start a new list. Okay, 5. Now, what should be the count of 5? Now you look at the 5 will be coming somewhere here, right? Somewhere here between 9 and 2. So what we will find, what is the smallest number, what is the greatest number is smaller than 5 in this list, the earlier list. Okay, if you find that, now what should be the count? So this guy's count is 3, right? And this guy's count is 2. So this 3 has come from this count, right? But 5, so 5 will not start from 5 9 2, it will start from the 2. So what is the actual count of 2? So what we'll do, we'll just do the subtraction between these two count. So 3 minus 2. Okay, and nothing is here in the earlier, right? So 3 minus 2, 1. So I'll make it 1. Okay, now 3 3 has come. After 5, we have a 3. So 3 will replace 5. So that should go here. Okay, 3. Now what should be the count here? Okay, to get the count, what we'll do? So again, so to make this sequence, right? To make this sequence, what we'll see? What is the position of 3? So 3 can be here or 3 can be here. So we'll start. So what we'll do? We'll take the all the numbers, right? 10, 9, 2. These are the numbers 5, and we'll find where should it be. This 3 should lie. So 3 should lie somewhere here. Okay. So what is the count? If it should be here, then count would be 3 minus 2, that is 1. Okay, then it should be 1. But what is the earlier count in this array? It's 1. So 1 plus 1. So this should be 2. Okay. Now 7. 7 is bigger than 3. Yes. So 7 would be new value. Right. So what should be the count of 7 now? Okay. Now we'll look at the earlier list. 7, where 7 should be placed. So if you look at carefully, right? So the numbers, the earlier numbers, right? So kind of this is 5, this is 3. So 7 will lie somewhere here. Nice. The 7 is satisfying all this, right? So in the sense it can be 2, 5, 7, 2, 3, 7. So I'm considering both the number, right? So that means that's the reason I'm telling the 7s will be lie somewhere here. That means what I mean to say lie is that which count we should take. So because 7 is satisfying both the things, so I'll take the last count. So last count is 2. This will be 2. Good. Now 101. 101 is again a new number. So I'll add 101. We'll look at the earlier one. So 101 is again satisfying this part. So 101 and 7. That means 7 and 101. So 2, 3, 7, 101. So 101 is somewhere coming here. So what is the count? 2. So we'll just simply take a 2. Okay. Now we'll look at the next number is 18. 18 will replace the 101. Okay. If it is replacing, it's good. So what we'll see? What is the count? So we'll again look at the previous one. Okay. 18 is satisfying. So 2 is the count. Right? 2 is the count. And what is the count earlier in this list? So it was 2. 2 plus 2, 4. Okay. And close it. We have reached to the last. So our count would be the last value. So the count would be the last array of last tuple and the last number. Okay. We'll do one more revision. Okay. So how we started? We started with the first number. First number is 10 and this list is empty. We simply added 10 and the count is 1. Then we again looked what is the next number. Next number is smaller than 10, then it cannot be a longest increase subsequence. Earlier what we used to do, we simply replace the 10 and put the 9. Here what we'll do, we are not removing the 9 from here, but we are increasing the count. So earlier it was 1, so not 2. So next number is 2. So again 2 is smaller than 9, so we are not going to remove, but we'll add in this same list, right? In the same list. Okay, in the same list. So 2, what should be the counts? So count is 3 because 2 plus 1 is 3. Okay. Now 5 has come, which is greater than 2. So we'll start the new list, and we'll add the 5. Now to calculate the count of 5, we'll look at the earlier list. Okay, where should this 5 be lie in this list? So this will lie here, right? After 9 and before 2. So if that is the case, then we'll take the count of if this is the index, so index minus 1, and then the count of index. I will take a difference. So 3 minus 2 is a 1. So 1 is the count of this one. If you'll see from here also, so 2, 5, right? Now the next number has come 3. 3 is smaller than 5, so we'll append here only. We'll not add the new element. Okay, we are going to append it here. What should be the count of this 3? So again, we'll look at the earlier list. Okay, the 3 will be lying here. So we'll take the difference of 3 minus 2, that is 1. And we already have a 1 list available here, 1 value, this is a 5, and its count is 1. So this count would be the 2. Because 5 and 3 are basically 2, 5 is one option, 2, 3 is another option. Okay, there's the intuition. Okay, now 7 has come. 7 is greater than 3, yes. So we'll start the new one. We'll not append in the earlier list. We'll start the new one. And what should be the count of 7 now? We'll look at the earlier list. 7. Where should be 7 lies? 7 will lies here. 7, 5, 3, right? 7 will lies here. If 7 will lies here. What should be the count? Then we'll take the, what is the count? The last count. Last count is 2. So this would be the 2. Okay. Well, now the 101 has come. 101 is greater than 7. Yes. So we'll start the new list. So 101. What should be the count? We'll look at the earlier list. Okay. And 101 belongs to here. Since there is only one number, so this is 2. So we'll take the 2, the count of 101. That's good. Now 18. 18 is smaller than 101. So we'll append in this list only. Okay. And what should be the count? We'll look at the earlier list. We found 2 is 2 from the available list, and because we have one element here, so we'll take the we'll take the value of the count of this number. So this is 2. 2 plus 2 is equal to 4. So 4 is the output. Okay. What we'll do? We look at another example also. So the example which is given in this in the same earlier question. So let me take one example. So it's a 1, 3, 5, 4, 7. Okay. Probably this is the example here it's given. Yeah. 1, 3, 5, 4, 7. This is what we talked on. So, okay. Now, if we would have to find only the number of elements in the increasing subsequence, the longest increasing subsequence, then what we could have done, we started with the 1. Now 3 is greater than 1, 3 will be added. Now 5 is greater than 3, 5 will be added here. Now 4 is smaller than 5. We'll do the binary search, find the position of 4. 4 will be somewhere here. So it will replace the 5 and put the 4. Now 7. So 7 is greater than 4, so we'll add. So this is the longest subsequence, 1, 3, 4, 7 or 1, 3, 5, 7. We have two options. So there are two possibilities, right? And the longest subsequence is 4. But we have two possibilities. Now we'll have to find how many possibilities from our earlier method. We'll create a list and we will start with a new list having element 1 and the count is 1. Okay, now we will see what is 3. 3 is greater than 1. Yes. So what we'll do, we'll start a new list with the 3. And what should be the count of this 3? We'll look at the earlier one. Okay, earlier one, there's only one number and the count is 1. So here also we'll count 1. Okay, what is the next? Next is 5. 5 is greater than 3. So we'll start fresh. 5. What should be the count of 5? So we look at the earlier one. The only one item is there. And the count is 1. Okay, so count is 1. What is the next? Next is 4. 4 is smaller than 5. Yes, so we'll add 4 here only in this list. What should be the count? We'll look at the earlier one. There's only one item. Its count is 1. Okay, and there's one more item here whose count is also 1. So 1 plus 1 is 2. Okay. Now there is a 7. So we'll add the 7 with the new list. Okay, what should be the count? So we'll look at the earlier list where the 7 will lie. 7 will lie is here. Okay, at index 0. So if that is the case, we'll take the count, the last count. That is 2. Okay, and then the 2 is the answer. Right? Hope you understood this. We'll take one more example, some sort of edge cases. So 2, 2, 2, and 2, the easiest one. So to find the longest sub increasing, what we could have done, so the first item 2, and then again it is a 2, so because it's a 2 it will replace the 2, right? Again 2 it will replace the 2, again 2 it will replace the 2. So longest increasing subsequence length is equal to 1. And how many such possibilities are there? So 1, 2, 3, 4. So such for possibilities are 4. Yes, okay, we will look at here the method we have built. Okay, so we will start from first number 2 and count is 1, right? Now again 2. So 2 is greater than 2? No. So we'll add here. What is the count? We'll look at the earlier number. It's 1. We'll add 1, 2. Okay. Again 2. 2 is greater than 2? No. So we'll add here. What is the count? So count would be, we'll look at earlier number. So this is the 2, right? So count would be 3. Okay. Next again 2. Look at the earlier number. So count is 3. So this should be 4. 4 is the answer. Okay. So now if you'll see for all this what we are doing all the times. So for adding each element like 10, 9, 2, we actually look at the position where it has to be added. Okay, I'll take just one more example. That's good example. Okay, for better understanding. Okay, I'll take one more example. It's 0, 1, 0, 3, and then 2, 3. Okay, this is a good example. So now I will take the 7 to school list. How we will start? We will start from 0. Count is 1. Okay. Now 1 is greater than 0. Yes. So we will start the new one. Okay. What should be the count? We'll look at the earlier array. There's only 1. So 1 is there. So the count would be 1. Okay. Now 0 has come again. Right? So 0 is smaller than 1. Correct? So we are not going to add new one. But we have to find where this 0 should be lie. Here or here. So what we will do, we'll find the place. So now what we used to do, we will look at the earlier one, right? So earlier is here, there is only one number 0, compare with the 0, and 0 is lying here only in this one only. This is the index 0. So basically we find where this 0 will be lie. Okay, so this is the place, this array. So what we'll do, we will 0, 1, the first one, and we will add the 0 here only because the index is 0, and we look at where this 0 should lie. And then this is a 1, we'll add it will be a 2. Okay, and now it was 1 and 1, no problem. We'll look at the next number. This is 3. 3 is greater than 1. Okay, we'll add 3 here. What should be the number? We look at the earlier one. This is 1, so this should be also 1. Okay. Now what is the next? Next is 2. 2 is smaller than 3. Now we'll find out where this 2 will lie, right? So we'll look at the earlier one. There is a 1. Here is one number, and there is a 0. 0 and 1. So this means 2 will lie here only, right? Okay. What should be the count? For count, we'll look at the earlier one. The count is 1 here, and the count is 1 here. So 1 plus 1 is 2. Okay. Now close, because the next number is 3. 3 is greater than 2, right? So add here. What is the count of 3? We'll look at this one. where this 3 lies. 3 lies here, right? Okay. 3 is exactly equal to this 3. 3 lies here. What is the count of 3? This count is 1. Okay. And anything here to add? No. This would be 1. The answer would be 1. This is the longest increasing subsequence. The subsequence will be like 0, 1, 2, and 3. And then 4. How many such possibilities? There's only one such possibility. Okay, that's good. So now we'll look at the code. If there's any confusion, we'll again understand the code, so understanding will be more. I'm switching to the code now. Right. So the code is very much resemblance of what we have our understanding. So we'll first define the list as an empty list. Now we'll iterate the numbers for n in nums. Okay. Very initial condition if length of 7 list is equal to 0, means if it is empty, then what we are going to do, we'll just add it, right? So append, okay, the n and the count would be 1. The very first thing. No, it's if the if okay, if this number, the second number is greater than 10, then we are going to append, right? So this here is 5. 5 is greater than 2. We are appending. This is what the condition will look here. Okay. So if sub underscore list, the last array, right, and the last element in the last array, and the value, the first one. So I'll just to understand here. So I'm talking about when I'm comparing with this one, right? So the last array and the last array with the last element, right? So 7 list minus 1 and the minus 1 and this is 0, the first element. I'm comparing with the new number. Okay, so that's what I'm writing here. So minus 1, 0, if this is smaller than n. Okay, then what we are going to do, we are going to append. Okay, 7 list dot append what n and then count, right? What would be the count? So to know the count, first we'll have to look at where this n will be lies, right? So to know that, we'll get the last array, okay, and then the first element, right? So for as in sub underscore list of last two. There may be multiple numbers, right? So I'll take this one, and then we'll find out where is the position of this n. So to take the position, we'll find out what is the find the smaller number, right? In the last array, pass the n. What actually we are doing here? We will be getting the get the index of greatest number which is smaller than n. Basically what we are doing now to find the 5 where it will be here, right? So greatest number is smaller than 5. So this is the position 2 here. For example, here it's a 2. That's what exactly we are doing here. Find is smaller. This would be the binary search and login time. Okay. Now, so once I'll get the position, so what we do for the count, once we get the position, here, okay? So 2. So we'll take what is the count of this one and what is the count of this one and subtract, right? So if the index position is position, so position's value, and then just before a position value, the counts. That's what we are going to do here. So sub underscore list, last one we have taken, and then the position. What is the position now? So the position would be the last here. So I'm just taking the last only, and the count is last minus sub underscore list. Okay, last array. What is the position minus one earlier, and then 1. Okay, if position is greater than 0. If we found the zeroth, then this will not work, right? So in that case, else we'll take the sub underscore list last value minus 1, and then 1. So this would be the count of our this part. Okay, there is one more condition. When this is not less than n. So this condition what I am talking about, this value, if there is a n, right? So if this is a n, then it will replace this guy. So what we are doing here, you are taking the n and then count of this plus this, right? So that is the case. And so if this is the one array, if we have an array, if you look at here, this guys, what we have done, we first found the position of 18, where this 18 is lying with this array, and then so that is the position. Just an example here we have done for 0, right? For 0. So when 0 has come here, we found what is the position of 0 from the given arrays, right? 0 and 1, where 0 should lies. We found the 0th is lying here. Then we found what is the count, right? So first we found what is the position. Similarly, for 3, what is the position? So we found the position should be here. What is the count? So for count, we look at the earlier array, right? And then we did this subtraction. And if there is one more value, 1 here, so 1 plus 1, 2. The similar thing we are going to code here. So first of all, we found sub array. So sub array would be the last element, and then 0 number. Okay, for array in 7 list. Let me again show you what I am doing here. I am trying to find out the position of this 0 when I took a 0. So we have this part, right? So what we'll do, I'm taking here basically what I am doing now. 0, this array is 0, and this 1, and now I'm checking where the new 0, the 0 will lie, here or here. So we found it is on the index 0. This index is nothing but the index of the array where the 0 will lie. That's the same thing we are doing here as well, for others part also, but because the situation is not arrived, that is the reason I put this example also. For all the situation we are appending here only. So just an example. Okay, we see if we have to place the food. Okay, what we are going to do, we'll take this 1, 3 and 5. So between 1, 3 and 5, where this 4 should go. So 4 will of course go here, right? So between 3 and 5. So my index would be 5, right? This index 5 is nothing but the index of array where this 4 will go. That's the reason I'm appending the 4 here, right? You got the position. You probably understood. Let me code then. Okay. So I have taken the sub array. Sub array is having the last element of all the sub arrays. Okay. Now I found what is the index of array where this number will lies. So I'll call one method find index of in the sub array, and what is the n. Okay, what actually I'm doing here is to find the index of array having smallest number greater than n, right? That's what I am doing here. Okay, now this define count is equal to 1. Okay, if index is greater than 0, okay, if index is not greater than 0, if index is not greater than 0, that is means index is always 0. So if that is the case, what should we have done? Sub underscore list, okay, at this index, append. What we'll have to append? We have to append the n and then count. Count plus of what? Count plus of sublist index minus 1 index minus 1. 7 underscore list, the last value, minus 1 minus 1 1, right? That's right. But if index is greater than 0, that means we have some different array. Then what we'll do? We'll take the earlier arrays and find the count the way we have done here, right? Right? So we found the first position and then count. We'll repeat the same thing here again. So if that is the case, we'll find the last array. Last array is equal to x of 0 for x in 7 underscore list, where not the last one, the index where this will be lies, right? So sorry, idx and this should be the before one, idx minus 1, right? Here only the earlier one. So I got it, and then now got the position where it should be. So find this smaller, we'll call this only, and what I am going to do here is the last array and value, get the index of greatest number smaller than n. I got this one. What I'll do, I'll calculate the count. So now count is equal to similarly 7 underscore list, right? And idx minus 1, correct? And is last values in the position minus the same array 7 underscore list of idx minus 1. What should be now the position? So it should be position minus 1, right? So okay, my position minus 1 and then the last value 1, correct? Only thing is that if position is greater than 0, if not, then 7 underscore list idx minus 1, alright, minus 1 and 1, correct? So if that is the case, now we found the count. So count plus 7 underscore list minus 1 minus 1. Okay, this is possible when we have a data. So there is one condition also here. Sub underscore list minus 1 is only possible when if I have a data in the sub underscore list of what? IDX. Okay, one more mistake I have done here. It should be the IDX. And then it should be the IDX. Correct? Is greater than 0. Else, just take the count, which I've already defined it here is 1. So it will just add one more, right? So now this is done. So we have created. So into our for loop will end and will simply return the sub underscore list -1, the last array, the last value, and the count. Correct. This will work. Now we have to define the two method what we have written, the find smaller, right? So define find smaller is array and n. What actually find smaller we are finding? Get the index of greatest number smaller than n, correct? And what is this array? Is it somewhere in the increasing and decreasing order? Okay, if you see here, x0 for x in the sublist of -1. So any of the last array we are taking the 1 value. If you look at here, so just an example bigger one. Okay, here you will see the 5 and 4, one of the array, right? 5 and 4. So x0 is 5 and x0 is 4, right? So I'm taking the x0 of each element. So there's 5, 1, 4, 2. So I'm taking the first value, right? So 5, 4. It's actually going in the decreasing order. Look at here. 10, 9, 2. It is in the decreasing order. So when I'm trying to find out the position of given number n, I'm actually trying to find the position of given number n in the decreasing order array, right? That's where our code should be. Okay. Now it's similar to the binary cell. So we'll start write the start index is equal to 0 and index is equal to length of array -1. It's a normal binary source code. And start index should be smaller than the end index. Okay, we will find the mid is equal to start index plus end index minus start index divided by 2. Okay, now if array of mid array of mid is smaller than n, if it is smaller than and it is in decreasing order, what we'll do, and index is equal to mid, right? Okay. Else the start index is equal to mid plus 1. Hope you understood this one, right? So it is in the decreasing order array and we want to find out the index of greatest number is smaller than n. So should be smaller than n and we found the greatest number. So that is reason if the mid value is smaller than n, right? So that means we have to look at the first half, right? So that's the reason I am made it end index is equal to mid. Otherwise we'll have to look at the another half. Okay, and then return start index. Okay, now there's another method is to get the index, right? Find index. What actually we have to find the index of array having smallest number, right? So this one, if you recall in our earlier video, this is in the increasing order, right? I will do the same thing and just copy paste here. Only difference is that here, so in place of array mid is less than n, should be greater than equal to n, and end index is equal to mid, otherwise start index is mid plus 1, return the start index, exactly opposite of that. Okay, so we'll look at the code again what we have done. So iterating on the n, and then if length is equal to 0, and then we are simply appending. If it is less than n, so we are actually appending the new value with the count. For count we are finalizing, so we will check the last array and find the position of this n and do the subtraction from the earlier one, right? -1 and position -1. If position is greater than 0, if it is the first one only, then we do the minus and minus and append this value, right? Okay, now if n is greater, Then what we'll do, we'll find out in which array it will be. So I'm taking the sub array, okay, all the item, the first item, and this is the decreasing order sub array. We find the index. Now we found which array basically we have to look at. And now we'll do the same thing. We'll find the position, we'll find the count and append. So here we find the position, we find the count, we are appending in this index, right? So there's a difference. Here we are adding directly new item. Here we are appending at this position. Okay. Now we'll just run. So okay, we'll look at the time complexity after running it. Okay, now both the test cases, simple test cases pass. Submit this code. Good. So this is submitted now. All test cases are passed. Now we look at. So what we are doing, we are actually iterating all the numbers n times, and for each number we are actually calling the binary search for 2 times, right? So it's a logn and logn, and but n times. So this complexity is n logn. Okay. So let me know if there is any improvement needed in the videos. I'll try to add here. Thank you for the watching. Have a nice day. Bye bye.